This is part 2 of China's mega project revolution, and now we go deeper. Imagine a laboratory at the bottom of the ocean, a skyscraper that reshapes an entire city district, and a grand opera house that turns architecture into art. These aren't dreams, they're happening right now. Welcome to part 2, Carving the Future. Deep Sea Space Station, the Cold Seep Laboratory. Far beneath the waves of the South China Sea, China is constructing a manned deep-sea laboratory that some have likened to an underwater space station. This facility will be anchored at a depth of 2,000 meters in the darkness of a cold seep ecosystem, areas where methane and other hydrocarbons naturally leak from the seafloor. Nicknamed the Deep Sea Cold Seep Lab, it is the first of its kind, a permanent underwater research station that can accommodate up to 6 crew members for 30-day missions on the seabed. Launched in early 2025 in Guangzhou, the project is a mega science infrastructure led by the Chinese Academy of Sciences. It consists of 3 main parts: the manned subsea lab itself, a surface support vessel, and a land-based simulation facility. The lab, weighing 600 tons, will house multiple specialized cabins for experiments, navigation and control, living quarters, and power supply, and will integrate both manned and unmanned technologies. Notably, China is developing new deepwater docking and hatch systems to support this station, extending underwater engineering capabilities from the current approximate 500 to 700 meter depth range to 2,000 meters. This enables safe crew transfers at extreme depths and enhances China's ability to conduct deep-sea rescue and salvage operations in the future. Why focus on cold seeps? These habitats, first discovered in the 1980s, are rich in methane hydrates, also known as combustible ice, unique life forms, and clues to the origins of life. China sees strategic value in studying cold seeps for both energy resources and biodiversity science. By having scientists on site 2 kilometers underwater, China hopes to achieve breakthroughs in understanding these extreme ecosystems and in tapping undersea energy in an environmentally sound way. The project is open to international collaboration and is framed as an internationally open mega science facility under initiatives like the UN Decade of Ocean Science. Construction of the Deep Sea Lab is expected to take 5 years, 4 years of building and 1 year of testing, meaning it could be operational by 2030. When finished, it will be a symbol of China's oceanic ambitions, akin to a space station on the seafloor. Strategically, maintaining a long-term presence in the depths of the South China Sea reinforces China's stake in this geopolitically vital region. Technologically, the lab pushes engineering limits. The pressure at 2,000 meters is extreme, fault zones and corrosive saltwater pose serious hazards, and ensuring human habitability is no trivial matter. Overcoming these challenges will advance China's expertise in submersibles, material science, and autonomous robotics. As President Xi said, the ocean deep is the next frontier in building China into a strong science and technology power. The Deep Sea Lab, like an inverse skyscraper, exemplifies that frontier spirit. Suzhou Tower and Suzhou's ITC complex, sky-high ambitions. China's infrastructure boom isn't confined to transportation and energy, it's also reshaping city skylines with super tall skyscrapers. 2 notable examples are the proposed Suzhou Tower and the ITC Suzhou complex. While many details about Suzhou Tower remain under wraps, it is rumored to aim for heights above 500 meters, continuing China's trend of constructing futuristic high-rises that serve as business hubs and urban landmarks. Meanwhile, in the city of Suzhou, Jiangsu Province, the ITC Suzhou project is well underway. Backed by Hong Kong developer Sun Hung Kai, ITC, short for International Trade Center, features a 310-meter tall main tower accompanied by a mix of office, retail, and residential space. This complex, set on the shores of Jinji Lake in Suzhou Industrial Park, will be the city's first truly super tall skyscraper. Suzhou's current tallest building stands at 450 meters meters, but that structure was scaled back due to a nationwide height regulation. The new ITC tower, a sleek glass needle, will anchor a 66,000 square meter lifestyle center and required engineering a foundation pit 37 meters deep into soft soil by the lake. With 64 stories planned, it is expected to open by 2025, adding another jewel to Suzhou's skyline. These skyscraper projects reflect more than architectural ambition. They tie into broader economic strategy. Cities like Shenzhen, Guangzhou, Wuhan, and Suzhou have all vied to host the tallest towers to signal their emergence as financial and innovation centers. However, in recent years, the central government has imposed stricter limits on super tall buildings, generally capping heights around 500 meters, to curb vanity projects and safety risks. If Sujiwei Tower goes forward, it will need to comply with those regulations. Even so, the drive to build smart, green high-rises continues. Modern Chinese skyscrapers adopt advanced wind-damping systems, energy-efficient facades, and LEED-certified designs. For instance, designs in Suzhou incorporate sustainable technologies like rainwater harvesting and double-skin facades to reduce cooling demand. Geopolitically, China's urban megatowers often become symbols of national pride and soft power. Much like the Burj Khalifa is for the UAE, the construction of these towers trains domestic architects and engineers in high-rise construction, a field once dominated by Western and Japanese firms. Now, Chinese firms routinely win international design competitions. Projects like Sujiwei and ITC Suzhou demonstrate China's homegrown capability to build to the clouds. By clustering offices, hotels, and malls into vertical cities, they also support urbanization and economic growth in a land-efficient manner. In short, from the mystery-shrouded Sujiwei Tower to Suzhou's sparkling new skyline centerpiece, China's high-rise mega-projects embody the nation's lofty aspirations, reaching new heights in modern architecture. Shanghai Grand Opera House, a cultural mega-project. On the banks of Shanghai's Huangpu River, a dramatic new form is rising, the Shanghai Grand Opera House, a world-class cultural venue that aspires to be for Shanghai what the Sydney Opera House is for Australia. Designed by Norwegian firm Snohetta in collaboration with Chinese partners, the Opera House features a spiraling fan-shaped roof that evokes a spinning dancer or an unfolding Chinese hand fan. The roof's radial steps will be publicly accessible, allowing people to walk atop the Opera House and enjoy views of the city. Beneath this iconic roof will lie 3 state-of-the-art performance halls, a 2,000-seat main auditorium for operas and symphony concerts, a 1,200-seat secondary theater, and a smaller venue seating approximately 1,000 for experimental performances. With multiple halls and extensive rehearsal and education spaces, the complex totals nearly 147,000 square meters in floor area. Construction began in 2019, and the project is slated to open in 2025, aligning with Shanghai's push to become an international cultural capital. The Opera House is the centerpiece of a new cultural district in the Expo Hotan area, site of the 2010 World Expo, and is explicitly named in China's national plan as a key initiative to boost Shanghai's global influence in the arts. It represents an investment of approximately 6 billion yen by the Shanghai government, marking one of the largest cultural infrastructure expenditures in recent Chinese history. The engineering of the building is as impressive as its ambition. The sweeping roof, appearing to float above a glass-walled lobby, requires complex steel truss supports and precise acoustic tuning to prevent rooftop noise from leaking into the performance halls. Renowned acousticians from Nagata Acoustics are ensuring the main hall achieves optimal sound quality, including a reverberation chamber and a movable acoustic canopy. The building exterior will include solar panels and self-shading louvers to align with the eco-friendly goals of the Haotan district, planned as a low-carbon neighborhood. When completed, the Shanghai Grand Opera House will be more than just an architectural landmark. Culturally, it signals China's confidence in its soft power, creating a world-leading venue to host everything from Peking opera to Western classics and experimental shows. It will provide a grand stage not only for performances, but also for cultural exchange, attracting top global artists. In the broader narrative of China's mega projects, the Opera House stands out as an investment in human infrastructure. in the arts, education, and urban quality of life. It underscores that China's development vision includes not just roads and power plants, but also projects that enrich society and preserve cultural heritage. As Shanghai's new cultural beacon, the Grand Opera House is poised to open both its doors and its fan-shaped roof to the world. Pinglu Canal, a new inland sea corridor. In southern Guangxi, China is digging a colossal new canal that will effectively redraw its maritime map. The Pinglu Canal, now under construction, will create a 134-kilometer, 83-mile navigable waterway from Guangxi's inland rivers to the Beibu Gulf, Gulf of Tonkin, giving landlocked provinces a direct outlet to the sea. This is China's first major man-made ship canal in modern times, and is often likened to building a new Grand Canal for the 21st century. When completed in 2026, it will shorten the distance from river ports on the Xi River to the sea by up to 560 kilometers, significantly reducing transport time and cost. The canal's design is ambitious. It will accommodate 5,000-ton class vessels, roughly 90 meters long, about the size of small seagoing freighters, in a one-way channel. Because the canal must lift ships over a 65-meter elevation difference from the sea to the interior, it includes a system of 3 giant ship locks, including what will be the world's largest water-saving lock system. These locks are engineered to capture and recycle water between stages, saving 63% of water per locking cycle compared to conventional locks. The largest lock, at Madao, will manage a 30-meter elevation change in one go. The project requires excavating 339 million cubic meters of earth and rock, which will be reused to reclaim over 8.3 square kilometers of new land in the region. With a budget of 72.7 billion yen, about $10.5 billion, the project ramped up in 2023 after years of planning. The Pinglu Canal is part of China's Western Land Sea New Corridor initiative to boost development in the southwest and integrate with ASEAN trade. By opening a direct shipping route from the interior, starting at the Shijin Reservoir near Nanning, to Qinzhou Port on the Gulf, goods from Guangxi, Sichuan, Chongqing, and beyond can reach global markets faster. For example, bulk commodities and container barges will no longer need to detour east to the Pearl River Delta. They can go straight south. Officials project the canal will carry up to 89 million tons of cargo annually once fully operational. Building the canal has not been easy. The route traverses highly karst terrain and required careful design to manage drought conditions and ensure year-round water flow. Massive dredgers and explosives are carving out channels through what was once solid land. In essence, China is performing geosurgery on its landscape to create a new artery of commerce. Upon completion, the Pinglu Canal will stand alongside the Panama and Suez Canals as an example of how engineering can profoundly alter trade geography. It will also serve as a climate adaptation strategy, allowing low-carbon river transport to carry a greater share of freight and reduce trucking emissions. By literally connecting river to sea, the Pinglu Canal exemplifies China's willingness to execute bold infrastructure visions in pursuit of regional development and climate-smart logistics. From seafloors to skylines, the future is already under construction. But the next chapter takes us further, to tunnels beneath ancient mountains, solar walls across endless deserts, and military megastructures designed for survival. When part 3 is where ambition meets scale on a whole new level.